The correct type of wire for irrigation systems and public park systems that have multiple solenoid stations is direct burial rated and should be either single or stranded conductor, specifically type UFB wire, which must be rated for the system's voltage. UFB wire is a non-metallic underground feeder cable that is designed for direct burial, meaning it doesn't need to be placed inside a conduit. It's built to withstand moisture, abrasion, and sunlight, making it suitable for outdoor use. A common size for irrigation systems is 14 American wire gauge copper wire. It provides adequate current carrying capacity and is flexible, simplifying installation. In systems with multiple solenoid stations, each solenoid needs its own dedicated wire. This wire should run directly from the irrigation controller to the solenoid without any splices or connections along the way. Meg Ohm testing is performed to ensure the wire's insulation is in good condition and that there are no short circuits or ground faults. The specification of 50 megs is a high standard intended to provide significant safety margin. However, it can be challenging to reach 50 megs in practice, especially in wet or humid conditions. A reading of 5 megs is generally considered acceptable for a 24-volt irrigation system, assuming the wire is undamaged and all connections are secure. There are several factors that can make it difficult to achieve a 50 meg reading. Firstly, moisture can get into the insulation. Secondly, the wire may be damaged during installation. Thirdly, there might be improper connections. And fourthly, interference could arise from other electrical circuits. While contract documents may specify a reading of 50 megs, practical considerations are important, and a decision should be made based on the installation's specific conditions. A reading of 5 megs is usually sufficient for a well-installed and maintained irrigation system, as long as all other requirements are met. To elaborate on UFB wire, it's important to understand its construction and properties. UFB stands for underground feeder and branch circuit cable. It is manufactured as a solid core wire, but can also be stranded. This type of cable consists of one or more insulated conductors surrounded by a solid plastic sheathing. This sheathing provides excellent protection against physical damage and environmental factors. When installing UFB wire, it's crucial to follow all applicable electrical codes and manufacturer's instructions. This includes burying the wire at the correct depth, typically 18 inches, and using appropriate connectors and fittings. It's also important to avoid stretching or damaging the wire during installation, as this can compromise its insulation and lead to future problems. In situations where the wire needs to be run through a particularly harsh environment, such as rocky soil or areas with heavy foot traffic, it may be advisable to use a conduit for added protection. Conduit can also be used to protect the wire from damage caused by rodents or other animals. Regarding the use of 14 American wire gauge copper wire, it's essential to ensure that the size is adequate for the current requirements of the irrigation system. The current carrying capacity of a wire depends on its size, insulation type, and ambient temperature. It's important to consult the National Electrical Code, or NEC, Table 310.15b16 to determine the appropriate wire size for a given application. In some cases, a larger wire size may be necessary to prevent voltage drop or overheating. When working with multiple solenoid stations, proper wiring and connection techniques are crucial for reliable operation. Each solenoid should be wired with its own dedicated wire, running directly from the irrigation controller. This helps to minimize voltage drop and ensure that each solenoid receives the correct amount of power. It's also important to use waterproof connectors and junction boxes to protect the connections from moisture and corrosion. Splices should be avoided whenever possible, as they can be a source of failure. If splices are necessary, they should be made using approved splicing methods and materials, such as heat shrink connectors or waterproof wire nuts. It is important to perform regular maintenance on the irrigation system to ensure that all wires and connections are in good condition. This includes checking for signs of damage, corrosion, or loose connections. Any problems should be addressed promptly to prevent further damage or system failure. Now let's dive deeper into Meg Ohm testing. Meg Ohm testing, also known as insulation resistance testing, is a method of measuring the resistance of the insulation surrounding an electrical conductor. This test is performed by applying a high voltage, typically 500 volts or 1000 volts, between the conductor and ground. The resulting current flow is measured and used to calculate the insulation resistance in meg ohms. A high insulation resistance indicates that the insulation is in good condition and there are no significant leakage paths. A low insulation resistance indicates that the insulation is damaged or contaminated and may be prone to failure. Several factors can affect the accuracy of meg ohm testing. Temperature and humidity can have a significant impact on insulation resistance. As temperature increases, insulation resistance tends to decrease. Similarly, high humidity can lead to moisture absorption in the insulation, which can also lower the resistance. Therefore, it's important to perform meg ohm testing under consistent environmental conditions and to correct the readings for temperature and humidity if necessary. The type of test equipment used can also affect the result. It is important to use a calibrated meg ohm meter that is appropriate for the voltage and resistance range being measured. The test leads should be in good condition and properly connected to the conductors being tested. The duration of the test can also affect the results. Insulation resistance tends to decrease over time as the insulation is subjected to the test voltage. Therefore, it's important to allow sufficient time for the reading to stabilize before taking a measurement. Typically, a test duration of 1 minute is recommended. When interpreting meg ohm test results, it's important to consider the specific requirements of the application. As mentioned earlier, a reading of 50 megs is often specified as a minimum acceptable value for irrigation systems. However, this value may vary depending on the voltage, insulation type, and environmental conditions. It's important to consult applicable standards and guidelines to determine the appropriate minimum insulation resistance for a given application. In cases where the meg ohm reading is below the specified minimum, it's important to investigate the cause of the low reading and take corrective action. This may involve repairing or replacing damaged wiring, cleaning contaminated insulation, or improving the grounding system. It's also important to retest the insulation after any repairs or modifications to ensure that the problem has been resolved. In addition to meg ohm testing, there are other tests that can be performed to assess the condition of electrical wiring in irrigation systems. These include voltage drop testing, continuity testing, and ground fault testing. Voltage drop testing measures the voltage drop along a conductor under load. Excessive voltage drop can lead to reduced performance of the solenoids and other electrical equipment. Continuity testing verifies that there is a complete electrical path between 2 points. This test can be used to identify open circuits or broken wires. Ground fault testing detects the presence of current leakage to ground. This test can help to identify insulation faults and prevent electrical shock hazards. By performing regular testing and maintenance, it's possible to ensure that the electrical wiring in irrigation systems is safe, reliable, and operating at peak performance. Now to reiterate some points about reasons for difficulty achieving 50 megs in irrigation system wiring. Firstly, moisture in the insulation can significantly lower the insulation resistance. This is especially common in underground wiring systems where the insulation is exposed to damp soil. Over time, moisture can penetrate the insulation and create conductive paths that reduce the meg ohm reading. Secondly, damage to the wire during installation can also compromise the insulation and lower the resistance. This can occur if the wire is nicked, cut, or abraded during the installation process. It's important to handle the wire carefully and avoid sharp bends or stresses that could damage the insulation. Thirdly, improper connections can also contribute to low meg ohm readings. Loose or corroded connections can create high resistance points that reduce the overall insulation resistance of the circuit. It is important to use approved connectors and to ensure that all connections are tight and clean. Fourthly, interference from other electrical circuits can also affect meg ohm test results. If the wiring being tested is located near other energized circuits, stray voltages or currents can interfere with the test and produce inaccurate readings. It's important to isolate the wiring being tested from other circuits and to ground any nearby metal objects to minimize interference. Moving on to practical considerations regarding the 50 Meg Ohm specification, it's important to understand that this value is often based on ideal conditions and may not be achievable in real-world installations. Factors such as soil type, moisture content, and installation practices can all affect the Meg Ohm reading. In some cases, it may be necessary to accept a lower Meg Ohm reading if the wiring is otherwise in good condition and all other requirements are met. This decision should be made in consultation with a qualified electrical professional and should be based on a thorough assessment of the specific installation. Furthermore, it's important to consider the age and condition of the wiring when evaluating Meg Ohm test results. Over time, insulation can degrade due to heat, moisture, and other environmental factors. This degradation can lead to a gradual decrease in insulation resistance. In older wiring systems, it may not be possible to achieve a Meg Ohm reading of 50 megs, even if the wiring is still safe to use. In these cases, it may be necessary to implement a more frequent testing and maintenance program to monitor the condition of the wiring and to detect any signs of deterioration. In addition to Meg Ohm testing, visual inspections can also be helpful in identifying potential problems with irrigation system wiring. Look for signs of damage, corrosion, or wear on the wiring and connections. Pay particular attention to areas where the wiring is exposed to sunlight, moisture, or physical stress. Any problems that are identified should be addressed promptly to prevent further damage or system failure. Finally, it's important to document all testing and maintenance activities performed on irrigation system wiring. This documentation should include the date of the test results, any corrective actions taken, and the name of the person who performed the test. This documentation can be helpful in tracking the condition of the wiring over time and in identifying any trends or patterns that may indicate a potential problem. In summary, maintaining the electrical wiring in irrigation systems requires a comprehensive approach that includes proper wire selection, careful installation practices, regular testing and maintenance, and thorough documentation. By following these guidelines, it's possible to ensure that the irrigation system is safe, reliable, and operating at peak performance. And always remember to consult with a qualified electrical professional for any questions or concerns regarding irrigation system wiring. They can provide valuable insights and guidance based on their knowledge and experience. The National Electrical Code, specifically Article 547, covers agricultural buildings and systems. Although irrigation systems are not explicitly mentioned, the principles of wiring in wet or damp locations apply. UFB cable is often used because it is designed for direct burial and is resistant to moisture. NEC Section 300.5 covers underground installations, specifying burial depths and protection methods. The depth depends on the voltage and location, typically 18 inches for residential applications. When running wiring for multiple solenoid valves, use a multi-conductor cable or individual conductors bundled together. Secure the wiring to prevent movement and protect it from physical damage. Direct burial cable should be buried deep enough to avoid damage from gardening tools or foot traffic. The individual solenoids are typically 24 volts alternating current, so ensure the wiring and connections are rated for this voltage. Use waterproof connectors and enclosures to protect the connections from moisture and corrosion. Proper grounding is essential for safety and to prevent electrical shock hazards. Ensure that the system is properly grounded according to the NEC. A ground fault circuit interrupter, or GFCI, is also recommended for additional protection. Periodically inspect the wiring and connections for any signs of damage or corrosion. Replace any damaged wiring or components immediately. Keep the area around the irrigation controller and solenoids clear of debris and vegetation. Also, proper voltage is critical for solenoid operation. Low voltage can cause the valves to malfunction. Use the correct transformer size and wire gauge to maintain proper voltage at each solenoid. Another factor to consider is the wire color coding. Use different colored wires to identify each solenoid and the common wire. This will simplify troubleshooting and maintenance. Also label the wires and solenoids for easy identification. When installing the wiring, avoid sharp bends or kinks. Use cable ties or clamps to secure the wiring and prevent it from rubbing against sharp edges. And check the voltage at each solenoid to ensure it is within the acceptable range. Use a voltmeter to measure the voltage while the solenoid is activated. Finally, keep records of all wiring and maintenance activities. This will help you track the performance of the system and identify any potential problems. Remember that working with electricity can be dangerous. Always disconnect the power before working on the wiring. If you are not comfortable working with electricity, hire a qualified electrician. NEC Article 430 covers motors and motor circuits, which may be applicable to some irrigation pumps. Ensure the pump is properly wired and protected according to the NEC. A separate circuit breaker is recommended for the pump motor. And also install a disconnect switch near the pump for easy access in case of emergency. Consider using surge protection devices to protect the irrigation controller and solenoids from power surges. Power surges can damage sensitive electronic components. Surge protection devices can divert excess voltage to ground, protecting the equipment. Check the local electrical codes and regulations for any specific requirements related to irrigation systems. Some jurisdictions may have additional requirements for wiring, grounding, and safety. Comply with all applicable codes and regulations. And always consult with a qualified electrician or irrigation professional for any questions or concerns. They can provide valuable assistance and ensure that the system is installed and maintained properly. Finally, here is a recap. Use USB cable for direct burial. 14 American wire gauge copper wire is common. Each solenoid needs its own dedicated wire. 50 megs is a high standard. 5 megs is often acceptable for 24 volts. Moisture, damage, bad connections, or interference can affect Meg Ohm readings. Consider practical conditions and consult a professional.